Hi, everybody. Welcome to this webinar about Apache Cassandra and how we have a nice little community extension for Camunda. This webinar is going to be a little more interesting than usual. It's based on the fact that I don't actually know a huge amount about Cassandra. And generally, when I don't know something, I have a tendency of asking my accidental co-host here, Daniel Mayer, about what exactly that is. So in this scenario, I'm just going to be asking him about the community extension that he created or helped create, all the how, why, when, where questions that may result in that. So I guess I'll start off by, you can introduce yourself there, Daniel. Who are you and why are you here?
Yes, thank you, Noel. I'm Daniel. I'm Camunda Technical Lead. Which means that I'm one of the developers that work on the on our product on Camunda, and I've been with the product for quite some time. And yes, so it's nice to sit down with you together here and talk a little bit about what we did with Cassandra. Yes, I think we should warn people. We don't have actually any fancy marketing slides. We haven't actually prepared a lot of things, but I think it's still going to be pretty interesting, I hope. But now that I have introduced myself, I noticed that you actually didn't. So you just said hello.
That's a fair point, actually. Yeah. So for those of you interested, I'm Niall Deehan. I'm a consultant here at Camunda. I sit very close to the product team, so close that I occasionally hear things that are going on and don't often have that much knowledge about what exactly they're planning. So this is kind of a nice little event for me to actually get to know a little more about some of the stuff that Daniel's been working on. So I guess first question for you there, Daniel, is why did you decide that Apache Cassandra was worth creating some community extension for?
Yes, interesting question. I think there are more than one answer to this, or there are more than one drivers behind the decision to do it. Well, one driver was probably that some guys here, mostly Sebastian and myself, we were interested in the technology. So Cassandra is obviously a very interesting database from a technological perspective. It's this distributed system where you can do very interesting things. You can control things that you usually can't control with a traditional relational database. For example, you can say, whenever I store data, I want to have so and so many copies of it on different machines, things like that. So that's something that's obviously interesting to developers. Yeah. So we like playing with that kind of thing.
Yeah.
So that was probably one of the drivers behind it. So our ambition to play with it. But there were different, or there were other drivers, and one that's probably more important is that people ask us about it. So we have people like, for example, our friends at Solando, who also did a prototype with it. So they also had a hack session where they just went for it and integrated Camunda with Cassandra. And that was interesting to see, and so we saw that there was some guys picking it up, and we wanted to participate in that. Then other people asked us too, and those people were Stan and Natalia Levine from Context Space, which is a Israel-based company, and they use Cassandra in production.
Oh, right. Okay.
So they approached us and they said, should we actually work on this together? So basically they wanted to have it for themselves. They use a system where they have Cassandra and Camunda, and they wanted to have it in their system. And so we got to talk, and they were pretty open to collaborating on this, basically.
All right.
And
when was this actually? How long ago was that?
Yeah, so that was in July, I think, the beginning of July.
All right.
We did a hack session here in Berlin together with them. So together with Stan and Natalia. And so they came here, we like blocked 2 days, and we worked on that. And the goal back then was to like evaluate, is this possible? And if true, what would be a approach to do it? And I think we were moderately successful in that. So we came up with an approach to do it. Obviously, there are open questions. We can get into that today.
Yeah.
But we came up basically with a way to do it. And it was cool, it was fun. And now the question is, will people like pick it up and take it somewhere?
Yeah, absolutely. At this point, I've already mentioned that if you guys listening have any questions, feel free to type them in the box there, and we'll get to them if we can. Meanwhile, I'm kind of interested. What sort of experience with Cassandra did you actually have before you started doing it? Did you leave it up to the other guys, or did you have enough experience yourself to be able to sort of make that extension?
Yes, so Sebastian and myself, we actually had no actual experience with Cassandra. We read about it, we used it in prototypes like many people do, but we had no real life experience with it. Natalia and Stan, they had that. So that's basically what they brought to the table. So we obviously know Camunda, we know the inner workings, we know how it works. Also, we know like the assumptions that are made and the architectural assumptions and so forth. And Stan and Natalia, they were like Cassandra experts, so they could answer all the questions we had about Cassandra. We could answer all the questions they had about Camunda. So from that point of view, it was a good fit, so to say.
Yeah.
And that's like the way we approached it.
And just did you like have any sort of features in mind for the engine that you couldn't actually achieve with a relational database that you maybe thought I could maybe, hey, if I do this Cassandra extension, I can maybe do this one thing that I've been meaning to do for a while? Or
I'm not sure from a functional perspective. I would argue that. So from a functional perspective, with the relational database, we're not at a point where we say, oh, we can get this done like functionally. Relational databases are very seasoned technology. There's lots and lots of things you can do. So the driver behind it wasn't so much a functional perspective. It was more that we looked at how this could scale if you do go to a large cluster deployment.
Yeah.
And there, obviously, Cassandra brings a lot to the table that some relational databases maybe can match. I don't know. But with Cassandra, you have this distributed system as a default. And that was what we were mainly interested in.
Sure. Could you actually describe Cassandra? Just what does it do? Like, what is the why them specifically? What is their?
Yeah, I could try.
Yeah, do your best.
It's a database, so pretty much everybody knows what database is. It's a system where you can like put your data in and query it, update it, delete it, and so from that perspective, it's just like a regular database. And what's different, like if you compare it to something like Postgre or MySQL or other like relational databases that you know, it's the way they store data. If you have a traditional relational database, usually if you have an instance of it, it will store all your data. Well, all instances will be stored in one place. I know it's not true every time, and there are exceptions to this, but that's basically the model. So you have one database, all the data is in there. And with Cassandra, they do this differently. So they say, well, there's not one node like hosting the database, but there can be many, many, many nodes. And each node will store a part of the data. So each node will not store all the data, but each node will just store. You can think about it. If you ever went, so you recently moved to Berlin, right?
Sure did.
So that was probably a very enlightening experience when you went to like the Bürgeramt, where you like registered and stuff.
Still nightmares, yeah.
Yeah, and there they have like these doors, these magical doors, and there are people behind it. And then I don't know whether that's like the way they do it these days, but basically there are many doors, and behind each door there's a person who can basically do the same thing, but you have to choose like the door you open. And the way this works is that you can like partition your last names. So for example, your last name is Dian.
Sure is, yeah.
Correctly?
Perfectly fine.
Yeah. So it starts with the D. So if you have like 5 doors, behind each door there's a person who can like process your registration. Then they can say, well, people that have a last name starting from A to, I don't know, up to D or some kind of letter go to the first door, the next partition goes to the second door, the next partition goes to the third door. I'm not sure whether that's actually how they do it, but that's really how Cassandra does it. So if they have a large cluster of nodes, they will just partition the keys, which means that when you store data, it's a primary key, and they will just check, okay, so you're inserting your data, on which machine does it need to be stored with an algorithm very similar to what they do at the burger mountain. Try to find the correct door for you. Is it
that makes a lot of sense, actually, yeah.
So that's one thing that makes Cassandra different. So this partitioning of the data. Another thing is that now you end up with all these copies. Like, for example, you say, I store an item of data, and then you can say, I don't just want to store one copy, but I want to store multiple copies. Because if I lose one machine, then it will still be stored on a different machine, and I can retrieve it from there.
Yeah.
And so they did data replication. And
how do they synchronize that?
Well, that's a very good question. So that's something that you can actually control. So when you, and I may not be like the definite source in this. So, but if you like update data, then you can say, I want this write. So that's basically write. You can say, I want this write to be successful on a single node or on all of the nodes. And all of the nodes meaning like everywhere where that particular piece of data is stored. Or you could say, I want to write operation to be successful for all of the nodes, which means critical mass. And that then is what they call consistency. So if you have very high consistency requirements, then you say, I want to write this to all the nodes that carry a copy. And if you have very low consistency requirements, then you can say, I want to read the write operation to be like just to be successful on one node synchronously, and then you can like replicate asynchronously. But if in the meantime you read from a different node that doesn't actually have the newest version of the data, then you may see an old version. So
okay, so it can be a bit dodgy there.
And that obviously makes it very interesting for a workflow engine.
Yes, like that.
Because a workflow engine obviously wants to have consistency at all times. So many people require that.
Yeah, of course. So how did you manage to deal with like that particular thing? Because obviously when you think about sort of the workflow engine, you don't want somebody to do some sort of work on a user task and then someone else then kind of show up and undo that work in some way, or take the old data and try and run some sort of service task on data that's now sort of expired. So how do you, is there a lock or something? Like how do you prevent that?
Yeah, so maybe I would what I could do is I could like mention some situations which are challenging, because you mentioned some of those. So imagine that you start a process, then there's a user task. So we basically wait at the task, and then somebody queries for the tasks and completes it. So now the task is completed, you give positive feedback to that person. Yeah, you completed the task, good job.
Yep, so
forth.
Pat and head.
But then some other user also like uses the user task, and what you want to like prevent is that another user then completes the task again. So that, and you also say to that user, good job, you complete the task. So that's something you would like to like avoid if at all possible.
Absolutely, yeah.
And there are mechanisms, or maybe an interesting question would be, how do we do that in the relational database? Because there we have the same problem, basically. And the way we do it there is we use transactions. And so when you look at a process instance, it's a complex object. It's not, it's not just one object. It's not like this is the process instance, but it has like many can have potentially multiple activities that are active at the same time. There's data, there's variables, there's tasks, there's jobs, there's events, subscriptions. There's many items of data that make up a individual process instance.
Yeah.
And what you want to achieve in a context like this is if you complete a task, then and move to the next task in a process, something like this, you want to make sure that all those updates either all succeed or all don't succeed or roll back.
Of course, yeah, exactly. Yeah.
This atomicity is what we achieve with transactions. So that's the first property we usually get from relational database that allows us to like make sure that we have no like partially incomplete state, like the variables are already stored, the user task is completed, but the process instance didn't actually advance to the next step. That would be something inconsistent.
Yeah, of course, makes sense.
And so that's something we achieve with the atomicity guarantee of transactions in a relational database. And then the second thing is consistency and isolation. So if you say I have now performed this atomic update of multiple entities, variables, tasks, and so on. After that, if I then read the state, I see it complete as a consistent state. I don't see just the update to the task, but not the update to the variables, something like this.
Makes sense, yep.
And so those are the kind of guarantees that we need for workflow engine, or that people expect the workflow engine to exhibit. And the interesting question is now, how do you do this with Cassandra? Because if we use Cassandra at its like weakest consistency guarantees, then you don't have this. And how did we achieve this? Well, we basically used the biggest hammer they have. It's like a combination of different factors. So the first thing we did is we used a data model which actually allows us to store the complete state of a process instance within a single row.
Oh.
In the relational database, we do this differently. We have, you notice we have different tables.
Yeah.
One for like variables, one for executions or tokens, stuff like that. One for user tasks. And here we said, okay, let's like flatten this and let's put the whole data that's or the complete data that's related to a process, let's put it into a single row. And then we can use a feature of Cassandra, which is called, I think sometimes they call it lightweight transactions, which basically allows you to do optimistic locking on a single row.
Oh.
So you can say something like, update this row, and this is the new state, so update it with this new state. Set the version to a new version.
Yeah.
If the version is currently the version I read. So going back to the example with the user task, the way the process engine works is it restores the complete state from the database.
Yeah.
Like everything that's in there, completes the task, then calculates the new state of the process instance, and then says to Cassandra, update the row with this new data object. I have read the version number 2. If that is still the current version, then only then actually do the update, and then set the state to like the new state and increment the version to 3.
Yeah, absolutely.
So, that's actually very similar to what we can do in a relational database.
Yeah, doesn't the job executor do that as well?
Yeah, the process engine does it like everywhere. Whenever we update a row in relational database, we do this kind of optimistic locking.
Okay, cool.
And Cassandra supports this as well. So,
but only if you have a single row.
And that's the thing. We need those two guarantees. So we need to be able to do an atomic batch. That's one feature they have. So multiple updates. They here all go into the same row. They have sub collections and things like that. So from the point of view of Cassandra, technically, like the list of executions, the list of variables, the list of tasks inside the processes are mapped inside a single row, so you can do partial updates to that, so you don't always have to like flush it all.
Oh wow!
It's very like complex, but we can like dive into the code in a minute.
Yeah.
But, so we can compare those partial updates to like the sub collections in that row with the version increment. And then if we combine those two, then we actually get consistent updates to that row. What's the downside? Like compared to relational database, Cassandra needs to run this consensus protocol, so this kind of update will actually update all like the core
of course, yeah.
And they have to like run a protocol where they synchronize all that, where they make sure that this version like this version increment is actually correct.
Oh, right.
Use something called Apache protocol, which I don't fully understand, but they support it, you can do it, and then you can actually have the same kind of fault tolerance and consistency guarantee.
Does that take a lot longer to actually write to like make a change like that when you're making a change to a single row, but it's then of course
and there's all the data in there.
There's all the data in there. Surely that makes that's a little bit slower than a relational database when you have.
Interesting. So we haven't benchmarked it, so I don't know. There's just like empirically, I don't know. I think Natalia has done some benchmarks on their like machines and so on. They have a larger cluster, as I understand it.
Okay.
But we haven't actually benchmarked it yet. But so what we still can do is partial updates in the sense that if you have a process instance which is composed of many tokens, so many executions, many variables, many tasks, even though we store all of that in a single row, when we update, we can do partial updates in the sense that if only one variable has changed and only the task has been completed, then we don't actually have to flush the whole process instance out, just the updates we did.
Then it still has to do that weird thing.
But then it just
then
it still has to. But then you apply it as a batch, and then Cassandra has to apply the batch like with that version update guarantee.
Yeah.
What they call lightweight transactions.
Oh, right.
And yeah, that has more overhead than just a simple like update in Cassandra. But whether it's faster or slower than
a relational,
there's probably not like one single answer to that. I mean, that's probably hard to follow if you don't like see the code. If you want, we could open your code.
Sure thing.
I'll do into it. And you could go to GitHub.
Sure. Can you see my screen? Okay.
Yeah, it's perfect. And if you go to GitHub and Camunda, you go to that GitHub organization.
Yep.
Exactly. There, like, find a repository search bar. You could type in Cassandra, and that's also the repository that we created for this.
Camunda Cassandra engine.
Yeah.
Okay.
And so this is basically where the code currently lives, and it only contains the Cassandra stuff, so it's not like a fork of Camunda BPM.
Oh, okay.
But it's just like a nice little extension which extends like the SPIs and other kinds of interfaces that we provide. And on the source, and then so on, you can find the classes. And go to provider actually, And what would be interesting is to just have a very small peek into the Cassandra persistence session, because this is where things happen. It's like the first class you find in the list. Okay. Yeah. And this is the implementation that we did basically back when we had the hack session, and Natalia has done quite some improvements since then and put in quite some features.
How long did the hack session actually last?
Well, we started on Friday and then Saturday. And Saturday was fun because it was actually very, very hot. And it was one of like the hottest days of the year here in Berlin. And
the office has no air conditioning.
Well, it hadn't. And so there was no air conditioning. But we have no air conditioning, but we have like a thermometer. So we actually knew how hot it was, but we couldn't like do anything about it. And like it was like 37 degrees Celsius or something here.
Oh my god!
And,
I remember.
So that was bad. And then basically what Stan did, and Stan is just such a cool guy. He just went to like MediaMarkt, bought an air conditioner, brought it here, and then we were able to like the very room we're sitting in today. We were able to air condition, and we brought down the temperature, I think, to about like something like 20 degrees. Oh no, that's not true. Like 24 degrees or something. But then it was decent. It was like
24 is livable. Yeah,
it was livable, right?
That's fine. Yeah.
And so that was good. And then I think we had from like 9 to 11 or something. And yeah, so that was Saturday. And then on Sunday, it was still pretty bad weather-wise. So it was too hot still. And Sebastian couldn't participate, and there he just did like 3 or 4 hours of wrap-up. And
oh, right.
so that was that.
And since then, there's been more.
Yeah, and Natalia has done quite some amazing work on it, I think, in the meanwhile. Yeah, but if you look into this, so what you see here is that we have the entities that we have in Camunda. So things like, if you go to like line 130 and so forth. 30. Yeah, so there you have like the entities that are currently supported there, and then they're mapped to like Cassandra persistence and so on. And what we actually do here is in the process engine, we have this expressive data model where we have, as I already mentioned, like executions and variables and tasks and all that kind of things. And here we still have these entities, but we just store them differently. We don't store them as like individual tables, but we store them sometimes as sub-collections inside a row of different tables, which
did you
is the data that Cassandra has.
Yeah, did you like write some sort of transformation sort of class or something to be able to like to hijack what the engine used to do when saving? Like what kind of manipulation did you have to do between, because obviously it's saving to a single row instead of
yeah. So
where did you actually catch that data?
Okay, so that's what happens here. So if you so we're implementing an interface here that the Camunda engine provides, and I think that interface is called persistence provider. And there you have to implement methods like select, which is about like loading data, which now works in a way that since we have a complete process instance stored in a single row, whenever we load something in there, we load all of them, all the entities embedded there.
Yeah.
So that's something we worked on, so that like then we could actually put all of that in cache. So whenever you load part of the process instance, it's loaded completely, and everything related to that process is put into cache. That was one thing we worked on. And what you said, then we have to, like when the command is complete, we basically flush out a minimal consistent set of changes. That's taken care of beforehand. So that's taken care of in a higher layer. That layer is called the DB Entity Manager.
Okay.
And so there, the process engine already calculates as I said, minimal consistent flush, which means that if you create something and delete it in the same command, you don't actually have to flush anything like that. If you load something but change it, you don't have to flush and update. So all of that is like dirty checking, all this aspect. All that is taken care of a layer above this. And then in the end, we are called with a list of things to do. And that method should be called something like flush. So if you scroll down, we should see that.
You see it there?
So yeah, okay.
Back.
So we have the commit here.
Yep.
And that's when we actually flush our batches. But there should be, So this is where we, as I said before, we calculate this atomic batches, which means that everything related to a single process instance would be a batch, an atomic batch. but you could do anything command. You could do work in more than a single process.
Cool.
Those would be like different batches then.
Yeah. Okay, so that's why it's got a collection there. And
Yeah.
Can you do that in the relational database as well?
Yeah.
Okay.
We do that there too. Here, obviously, one limitation shines through. So while we can actually in Cassandra have consistency inside a single process instance, if you have like a call activity invoking another process, that will be a different atomic batch.
Oh.
And then you could end up in situations where you like flush the first batch that is successful atomically and so on.
Yeah.
And then flush the second batch, which is like starting another process.
Oh dear.
And then that would fail. And that's
Yeah.
like the only limitation that we have in this. So whenever a single command does work in multiple process instances, then you could actually have inconsistencies.
Yeah.
But but consistencies in the sense that one changes to one process instance are flushed, but the changes to the other one are not flushed. None of them, so to say.
Yeah.
So it will still be like consistent within a single process instance. But you see what I mean, right? But not like So that was like one compromise.
Yeah, that seems fair enough.
Another one would be that you constrain the concurrency you can have, like the true concurrency that you can have inside a single process instance, because if you can have only one command doing an update at the same time, then they can only be thread active.
Yeah. Oh, right. Okay, that's kind of different actually, especially when you're using like. How does parallel transactions actually work with the relational database? Do you know? Or
we resolve. Yeah, this is also a source of conflict. If you have there are three things. There is joins. So whenever you join concurrency, there is conflicting things like continuing a task and concurrently canceling it. So you have a user task with a boundary event.
Yeah.
And the boundary event wants to cancel the task.
Yes.
And the user wants to complete the task. Those two things happen at the same time.
Yeah.
And there is a third one, and that's actually the simplest one. Two guys want to complete the same task at the
same time. Yeah.
And so those are the three concurrency conflicts you have. And we resolve those with optimistic locking in the relational database. We also do it here, but the difference is that in the relational database, we lock on the individual objects, on the individual executions. So if with the relational database, you have like a task on one parallel branch and a task on a second parallel branch after parallel gateway, then you can actually complete those concurrently, truly concurrently, as long as they don't join in the single transaction. But here in Cassandra, we lock on the processes. So the lock is much more costly grained.
Yeah, absolutely, yeah.
Meaning
every
that
token
you cannot have this. So even then you would have to retry one of the transactions.
Yeah.
But still, we felt that this is a good compromise. Because it's fundamentally, it's still optimistic locking. You still have to retry, so there's no fundamental change. Just you have to retry more transactions than with the relation.
That's not the end of the world.
And I see the use case for it, but I always think that concurrency within the process instance is often overrated.
Oh.
Because you could call activity and then call out to another process instance, and then many individual process instances.
I see what you mean, yeah. And maybe different rows in Cassandra as well.
Exactly, and they would be different rows in Cassandra.
Yeah, that's interesting. Now, you called this particular webinar super scalability, was it? And I'm just sort of...
Oh, was that me?
That was you, yeah. I remember very clearly. I remember thinking, oh, okay, is that what we were talking about? So I'm just wondering sort of what are the... why is it that Cassandra offers such scalability? I understand the benefits I can see to using Cassandra, but what about Cassandra with Camunda, and how can you scale Camunda better with Cassandra? Is there an implicit?
So so we're at the beginning with this. We're also not sure how many people want to use this, but this is something that we're currently learning. So at the moment, it's possible to do it. You can use this extension and try it out. And the assumption is that it will scale nicely because you have, with Cassandra, you have this, as we said before, this possibility to distribute data on multiple machines.
Yes.
And Camunda, the engine itself, you can already distribute it. So if you have a cluster, you know this, you can run the engine itself.
Because it's stateless, yeah.
Because it's a stateless engine, honestly, just kept in the database. And then if you have a relational database, and I know there are exceptions and so forth, but
let's assume that they're all the same. Yeah, let's make things easier. Yeah.
There, you actually have a single shared resource, which is your database. Yes, you can shard it. Yes, you can do things there, but like from the fundamental model, you have a single relational database. And with Cassandra, this is like your single shared resource that you cannot scale. With the disclaimers I make, but this is like the single resource that you cannot scale. And with Cassandra, the database is a distributed database. So like from the beginning, you can start with one or two, then you can add another one.
And you won't have to affect the actual engine. Yeah.
This promise of horizontal scalability.
Yeah.
And the open question is, how well does this scale with Camunda? Probably very well, because
probably very well. I'm convinced.
But it has to be tried out more thoroughly and investigated more thoroughly. But we are now here at a state where this is possible, where people can actually try it out and also then improve it. It's open source. It's
of course, yeah. And do you think if more customers were to use it, would you be happy to sort of say, hey, you know what, a lot of people are interested in Cassandra as a thing. Maybe we should spend a little more time than 2 days in the room, maybe trying to get it working.
Yeah. So
would you like to? That's something that you'd actually want to sort of get back to? Or?
Yeah. So I think there are two levels of support, so to say, and the first one is always, does it work? And then the second one is it supported in the commercial sense? And so this has currently a very limited scope in which it probably works.
Wow, that sure
in which it works well. We like have the tests and so forth where it works to a certain extent, which is already pretty cool, because if you think about it, the relational persistence, the way we do it, that is like an outcome and learning of the last 5, 6, 8 more years that we do that. And even like last summer, so not this summer, but last summer, we refactored it completely. So the way we flush things to the relational database. So, and this is something we're just starting on. But I think it's very, very exciting. And once we see more people working with this in terms of the community and using it in the projects and enhancing this, then at some point the question will be raised by people that actually want to give us money. We say, well, I want to use this in production and make it happen. And then if we have a critical mass of those people, then we would also support it commercially. Because that is not something, that's not a question about whether we like it or whether we don't like it, like it being Cassandra, but it's just a question of, are there enough people who want to do it?
Yeah. Well, they seem to see a benefit in using that rather than relational databases. Obviously, for scaling, that's the entire thing.
Scaling, and also, like, these days people start, there are companies who just run Cassandra. That's what they run. That's the database they use. And for those companies, it's like the natural thing is, if they use Camunda, is to run it on Cassandra.
Yeah.
Just in the same way that for other companies who just have been running DB2 for ages, those companies say, "Oh, now I want to run Camunda, but obviously it has to run on DB2 because everything else is running there." But now that things like Cassandra start getting more mainstream, I think we already hear this from people in the opposite direction.
Yeah, and is there fast adoption of Cassandra? Do you see it, like, do you hear it more often? Are people saying, "Oh, I'm totally going to abandon my database for Cassandra now because that's like the cool thing to do now"?
Yeah, probably for some people it's probably the abandoning. For others, it's just not starting with
they say, "Oh, let's quickly Google databases,"
and then
C comes before the other letters.
Interesting question. I think if it comes to NoSQL, the actual stats on this. But I think MongoDB is still more popular than Cassandra when it comes to just NoSQL databases in general. I think MongoDB is like the most popular one.
Yeah.
Could also be an interesting thing to run Camunda in that. So
would it be very similar? Have you do you think you've overcome a lot of the problems? Like, do you think as an architecture to communicate with a non-relational database? Essentially
we did it with Hazelcast too, which in a way is
of course,
database,
right? Yeah, exactly.
And we talked about this like 2 weeks back, and this like here with the new what we did here in this Cassandra session here, this is also a proof of concept of how to like have a different data model in the database than in the process engine, right? Just like, let's store everything inside a single row. In MongoDB, this would be a single document probably, a JSON document. And here you have like the blueprint of how can we flatten this expressive entity model that we have when like in memory when the process engine runs, but then in persistence have a different data model.
Oh yeah, because the runtime database was actually still relational, wasn't it?
Yeah.
So it was only when it flushed to the history database. So the engine was actually running on both the relational database to an extent.
You mean with Hazelcast or?
No, this guy here. Is this entirely? Do we change the runtime database?
Yeah, the runtime. Yeah, both.
So everything changed.
So actually, we didn't. So actually, we didn't implement history yet. So.
Oh no! I see. You only are doing
only
runtime. Well, who needs history? I mean, who needs to know what processes they're going to be running? Yeah.
Once they're done, right?
Yeah, exactly. Yeah, it's fine. Just like have a number saying, "Oh yeah, you did 4 process instances. Congrats." Hit the little pop-up screen. I'll use that.
No, I think there are very good reasons to do history, but that's also we have the Elasticsearch extension for that too, right? But yeah, so Cassandra I think it's gaining traction. I think it's also gaining traction with people, or it already has a lot of traction. There are many people using this. We had, I think, 4 or 5 interactions with potential customers who either wanted to run Camunda on Cassandra or who run other things on Cassandra.
Yeah.
In their
from folk as well about that. Yeah.
I think you had those kind of interactions too with.
Yeah, absolutely. Which is kind of why I have a tendency of seeing you in the sort of making your coffee, and I sit really close to the coffee machine, and generally speaking, I'm not allowed near the product team. So anytime I see somebody who could answer my questions, I have a tendency of maybe needing a coffee really quickly. And then I usually grab Daniel and find out, hey, Daniel, so, that Cassandra community extension, tell me everything. I usually only have until he finishes his coffee and escapes, but it's nice to find this out. It's a little nicer than having to try and mug you in the coffee shop.
So that's basically the story of how we did. Maybe it would also be interesting for people to know what's like the extent of the support.
Yeah, that'd be great, actually.
What actually does work and what doesn't. So the first scope that we defined together with Natalia really was to have. So we talked about user tasks a lot, right?
Sure did.
Those don't work. But we have interesting things running, and actually we have everything running that really turns this into a workflow engine. And we have persistence for executions, which is basically the token state of the process. We have persistence for variables, which is the data.
Very necessary.
And we have persistence for event subscription. And so you can correlate messages, which is interesting. So you can have message receive events, so you can wait for messages and then correlate them. So you can send in external messages. So you can have a process like a start event, invoking like a couple of services, doing exclusive gateways decisions because you have the data, right?
Yeah, exactly.
And then you can wait for messages, which is like what a workflow engine does.
It totally is. So it's kind of wondering at this stage, like you seem to have implemented quite a lot. Why did you decide user tasks could wait? Did you run out of time? Were they a little more complicated? Were they unnecessary?
Yeah, so the initial scope was to have like a executions, data, and message correlation, because that was also what they needed. So they didn't need user tasks in there.
I see.
And that was also the proof of concept, because user tasks are simple.
So I figured,
The most complicated thing about user tasks is actually to query, allowing people to find the right task to work on. But from a persistence core workflow engine perspective, it's fairly straightforward. If you can persist event subscriptions, then you can also persist.
Because you're just getting data that's been sent to the user.
That's the interesting thing. That's also one of the open questions in the Cassandra implementation here, is to what extent do you actually want to support your queries? Because we have this very expressive query API, and which allows you to formulate very complex queries. In Cassandra, whenever you want to query on secondary fields, you have to create secondary indexing. What's the English word for it? Indexes? Or
indexes.
What's the plural of index?
Indexes is fine.
Indexes.
Index I. Who knows?
Index
there could be. Do there's 3 plural for octopus?
No.
There's octopus, octopi, and octopuses. I know. Have a good day. Couldn't believe English. What the hell?
And is there a best way, or?
There's whatever way I decide.
Okay.
Today, octopi.
Okay. So great. So that's an interesting open topic, what to do about the index stuff.
Okay, well, we should probably, we've talked quite a lot about Cassandra for the last 50 minutes or so, and I think we can maybe call it a day. I think we got a lot of stuff communicated. If anybody has any more interesting questions, feel free to send us an email or contact us in the various other methods that we have, email and Twitter and whatnot. And if you enjoyed the chat and the format, please let us know as well. We might do more of these on various other topics. It's relatively informal, but I think it's...
People should also propose topics.
Very happy about that, actually. If people are interested in hearing sort of somebody who knows nothing talk to Daniel about various topics.
And it mustn't always be me.
It must always be Daniel. That's going to be something we're going to have to insist on. I'm not always a know-nothing, so that's perfectly fine. But as far as I can tell, you know most things about most things. That's, I think it'll be a constant feature of this. So do let us know. I'd be very happy to hear it. And if you hated it, then, sorry. Anyway, so again, thanks so much for watching this webinar. The recording is going to be sent out pretty shortly after this, I think. If not, then tomorrow morning. And thanks again for listening to us chat about Cassandra. And send us information on topics you'd like to hear us talk about, or anything else that might interest you about Cassandra, for instance, if we didn't answer some of your questions. Great. So thanks a lot, and goodbye. Say goodbye, Daniel.
Thanks. Bye.